Today's talk is about discovering a few applications and evaluation techniques for semantic search and retrieval augmented generation. First, a quick recap of semantic search. So let's assume we have this query: which cup went on a tour around the world? A bit strange query, but bear with me. And assume that we have this database with 4 sentences. Sentence 1 and 3 are talking about a cup, which is a utensil. And sentence 2 and 4 are talking about the World Cup. Okay? Keyword search may select sentence 4 and 2 as the top 2 results and give a response about the World Cup trophy tour. Whereas semantic search may choose the other 2 sentences from our database and produce the response about the cup, which is a utensil, given by Marco Polo. So let us now see very quickly why this stark difference of selection of the results between keyword search and semantic search. In keyword search, also known as lexical search, the words are matched between the query and the sentences in our database. So doing that, we can see the last sentence has the maximum number of matches, and sentence 2 has the second most number of matches of keywords between the query and that sentence. And that is why you see sentence 2 and 4 as the top results in keyword search. Semantic search, also known as vector search or dense retrieval, works in a very different way. It tries to understand the meanings of the query and the sentences using embedding vectors. So what you see here plotted are representations of the embedding vectors. We can see the query in the center, or the representation of the embedding vector of the query in the center. And we can see these two sentences. We can see these 2 sentences as being very close to the embedding vector for the query. And we can see these 2 sentences being quite far apart from our query. And that is why we see these 2 sentences as the top 2 results in a semantic search. Now, you may ask, which one is the correct response? Well, that depends on what you meant with the query, whether you meant cup as a utensil or whether you meant cup as a World Cup trophy, right? So there is no right and wrong here. Basically, both are techniques used in hybrid search systems. Most practical implementations of good search systems would take into account keyword search as well as semantic search as well as other signals and do some sort of aggregations. It will also do some sort of re-ranking and so on to create a proper hybrid system that is usable and meaningful. All right. Let us see this in action with Python code for a minute. Okay. The first few cells are just the setup, imports and keys that we need. Okay, so I'm just going to run them. We don't have so much time to go through the code in detail. I don't think that is necessary even. So the point here is to illustrate some key aspects of semantic search and RAG, so we'll do that. Okay. Right, so here are the sentences from our database that we saw a moment ago. And here is the function to create the embedding vector. We are using Embed English version 2.0 from Cohere. Cohere is a provider for embedding models and LLMs, just like we have OpenAI. It's also another provider. So let's run this. Here, in this cell, we are first creating a set of keywords for each sentence in our DB. How we are doing that is taking the lowercase of the lemma of the word. If it is not a stop word and if it is not a punctuation, then we take that as a keyword, but we take the lowercase lemma of it so that we don't miss out on detecting similar words which are basically the same but in different forms, right? So we take the lemma. And we also do, we create the vectors, the embedding vectors for those sentences, and we pack it into a data frame. This is what the data frame looks like after it's done. Is this still visible? Okay. Let me know if it is not. So we have the first column as the text, our sentences in our database, second keyword, and third the embedding vectors. So it's just a bunch of numbers, as you can see, the vectors, 4,096 of them. This particular embedding is using 4,096 dimensions to capture the meaning of whatever we supply to create the embedding vector out of it, right? There are other embedding models that would use 1024 or 512 or 2048 numbers to represent the meaning of whatever we supply to the model. This one is using 4,096. Okay. The next two cells are the functions that we will use to do our keyword search and our vector search. So how this works is, again, in the keyword search, first we create the set of keywords for our query, just like we did it for the sentences in our database. And once we have the set of keywords for the query as well as the sentences, we can then match and see how many of the keywords match between the query and the sentences, and we can return the one that has the most number of matches, which is what we are doing here. In vector search, instead of extracting a set of keywords, we are going to create an embedding vector, just like we did it for the sentences in our database, and we are going to apply dot product to the query vector and the sentence vectors. That would give us an array of numbers which we can use as match scores, and we can use that match score to return the best match, which would be the highest score. Okay, so with those two functions, now let's see how they pit against each other. If I pass this query to keyword search, let's see what the response is. It is what you saw in the slides. It is about the World Cup trophy tour. And if we do the vector search on the same query, we get the other response, which is about the cup given by Marco Polo. Okay, let's go back to the slides for some time. We have some more demos, so we'll go back and forth the slides and the demo. Now let us go through very quickly some applications of semantic search. Semantic search can be used to optimize our websites, our web pages for search engines like Google and Bing. It can also be used to elevate customer experience across websites and apps. We will actually talk about these two applications in a bit more detail shortly. There are other applications of semantic search, of course, like answering questions or research, or even something like monitoring the competition. So we have all seen over the years how semantic search has affected SEO, how it has affected search results. When you type in something in Google, it wasn't that long ago that you would just get plain links to web pages, right? I'm sure most of us remember that. But now you get a rich set of results, okay? What I mean by that is, just to refresh your memory, if I do a search like popular sites in Bengaluru, what we get is a rich set of results, not just links to web pages, right? I mean, links to web pages would also work. We could navigate our way through it, but this is much more useful and much easier for us to navigate and find what we want to, right? Okay. So how does this work, semantic search for search engines? Well, when we type in a query, like I just did, it not only extracts the keywords and the meaning from the query, but it also extracts and uses many other signals like location data, user history, and global history. All this is fed into the search engine. Now, what can we do to ensure that our web pages secure a good rank when the user searches for something relevant to our web pages in a search engine? The first thing we need to do is to shift our focus from keyword-focused content to topics-focused content. And that does not mean, of course, that we forget about keywords. That's still an important piece, because keywords are still extracted and is still used in the hybrid search engine overall. So we still need to make sure that our web pages have optimized keyword clusters. We also need to ensure that we have a good quantity and quality of schema markup, also known as I'm sorry, I forgot that one. Schema markup, also known as structured data, I think. So that is basically metadata, data about the content on your web pages. So that is also extremely important. And finally, we need to ensure a good site structure. That is the different types and numbers of elements, sections, pages throughout our website, and also their hierarchy. So if we do all this right, then we should be doing a pretty good job at SEO, at least regarding semantic search. There are many other parameters, of course. Now, for ensuring a good user experience, we can use semantic search to provide fast access to relevant content, because we have now access to the meaning and intent of the user's query, but also we have access to other features like spelling and grammar tolerance. So what does that mean? Well, I'm sure you have experienced that yourself, but let me just show you once. I'm just going to modify this query a little bit. So instead of popular sites in Bengaluru, I'm going to say popular sites on Bengaluru, okay? So obviously there is a spelling mistake here and a grammatical mistake, but Google is smart enough with semantic search to understand that I probably mean popular sites in Bengaluru, right? Additionally, we can provide more value to our users by personalizing the content that is fed to an individual user. And we can provide meaningful recommendations and suggestions to the user as well. A good example of this would be something we are all familiar with, Amazon shopping, right? So when you sign into Amazon shopping, everything that you see there is based on our previous purchases and previous searches, right? Okay. So RAG builds on semantic search. It's one of the important pieces in building a RAG pipeline. Before we do a quick recap of RAG, let us first look at what LLM generation looks like without RAG. Okay? So given a query, we construct a prompt with the query, and we pass that to the LLM to generate a response. Okay? That's pretty much how LLM works. With RAG, we first retrieve the relevant context given the query. Next, when we are constructing the prompt with the query, we also augment it with the retrieved content, the context. And finally, we pass that query, this prompt to the LLM to generate the response, right? In this slide, I try to highlight some of the important phases in a RAG pipeline. So the way we do chunking, that is the chunk sizes, breaking our documents into smaller pieces, that's very crucial. The embedding model that we use to create the embedding vectors, that's also crucial, because if you use a different model, you'll probably get different results. Next, the context retrieval. Do we get just one chunk? Do we get multiple chunks? How many multiple? Do we get a chunk window? So all these are important questions when designing your RAG pipeline. Here I am demonstrating a chunk window retrieval system. There are many more systems. And finally, the prompt construction itself and augmentation before passing it to the LLM is also crucial. Let's go through the applications very quickly. Some of the applications, there are many more, of course. So question answering is one of them, one of the prime applications, I would say. Statement verification or claim verification is another very important application of RAG. These two we'll actually see in the demo in a bit. RAG can also be used to create new content, right? You all know that. But it can also be used to enhance existing content. That is, you may want to augment existing content, or you may want to just rewrite existing content because it's poorly written. When an LLM produces a response that is outdated or no longer relevant, we can use RAG to mitigate that problem by sort of updating the model. Not really, but it's kind of a temporary fix. So we'll see that also, an example of that in the demo. Okay, before we come to the evaluation, we will go to the demo. Right, so we were here comparing keyword search with semantic search. After this, we have a function to evaluate search systems. Okay, we'll come to this function in a bit when we discuss evaluation. So I'm just skipping that for the moment. Now coming on to RAG, we first have the document chunking function. The chunking function simply uses Spacy's sentence-izer, which just extracts individual sentences. So this is relatively small chunks. You can have chunks that are just phrases. You can have chunks that are sentences. You can have chunks that are multiple sentences. You can have chunks that are paragraphs, entire documents, whatever suits your purpose, right? So this one is using just sentences as chunks. Next, we have a function to generate the vector DB. Well, sort of. It's not a proper vector DB like Llama Index is. This is just an in-memory pandas data frame that we are going to use here for the demo. Now, this document I took from the internet somewhere about Srinivasa Ramanujan. This is the text, a small piece about him. And we are going to use this function to generate the vector DB, splitting the document into sentences. This is what it looks like. So you have the sentences, the raw chunks, and the embedding vectors for them. Now we create the functions for doing the semantic search. So again, it's just a dot product between the query vector and the sentence vectors in our database. And this is a small helper function to show the results of the semantic search in a nice format. We'll use that just temporarily. Now let's ask a question. Let's ask a few questions. How did Ramanujan's career start? Now this is in context with the document that we saw earlier. So we are going to use semantic search to pull up the relevant context from the document and then do the generation. Okay, so the vector search results first give us these top 3 matches. Okay, the first match has a certain score, as you can see, the second one and the third one, right? The first result is, of course, quite relevant to our question. It does answer that quite well. The second question, how did Ramanujan reshape mathematics? It results again in 3 sentences. And the first one does answer the question quite well. However, you will see that the next 2 sentences are also kind of relevant to the question, right? About how Ramanujan reshaped mathematics. So this could be a problem if we just select the top result to feed in as the context in our RAG pipeline, or conversely, if we just join everything, all the 3 top results, then some result may not be relevant, right? In this case it is, but for example, in the previous one, the other 2 results are not really relevant to the question, right? Okay. So this question, was Ramanujan a fellow of the Royal Society? Again, we have 3 results, and the first one does have the answer to the question. Now we have the chunk window retrieval system. What this does is, instead of selecting just the best result as the context, it will include 1 or 2 sentences around that result to make a window. So here we have a function to do that. And of course, I'll be happy to share this notebook for you, with you, if you want to explore this and do your own experiments and take this further in any way. So here I am just putting a default size of 2 chunks before and 2 chunks after to make a window size of 5. Okay. All right, so let's do the same query, but with chunk window retrieval instead of just getting 3 results, which may be disparted. We will get just one best result, but augment that with 2 chunks before and 2 chunks after. All right. So the same query, how did Ramanujan's career start? So you can see that the sentence in the middle is actually, contains the answer to the question, given our context, right? But we include 2 before and 2 after, so that when we pass that context to the LLM to generate the response to our question, it may get more relevant information, right? Okay. So another question, again, we have just 3 sentences here because the third sentence is actually the one that, the first sentence is actually the one that answers the question, but there are no sentences before that sentence. So that is why just 2 more sentences are added after it, okay? And here, for this one, the answer is in the last sentence, but there are no more sentences after that, so it just adds 2 before it. Now you can modify the function as you please. If you want 5 sentences in total, regardless of where the sentence occurs in the database, then you can do that, okay? But here I have just truncated it, if it's the first or last, or if there are not enough chunks before or after. So let's create a question answering RAG model out of all the pieces that we have constructed so far. So here we have a prompt that will use the context that we supply and answer our question, and this one will generate the prompt actually, and this one will use the generated prompt to answer the question. So let's see an example. So asking the same question again, how did Ramanujan's career start? Now you will see a much more meaningful answer here because it extracted the relevant context, and the LLM is able to use its generation capabilities to rephrase the context into a proper answer. Okay. Next question, again, you will see that it is being answered very sensibly given the context. We saw examples of the context earlier. And this is also answered quite concisely. Yes, he was a fellow of the Royal Society, instead of giving us just the search results, right? It's a proper answer. We can also have similarly a statement verifying RAG model instead of question answering one. So we construct the prompt carefully, and we use that prompt to verify claims. And then we pass in a claim as a query to this function to see what it says. So we are claiming that Ramanujan's career started amazingly. Now this claim is refuted by our RAG pipeline, and it gives a supporting evidence that justifies the refute or support the verification, okay? Similarly, we can have other examples. This is refuted because he did receive a scholarship. This one is supported. This one will also be supported. Now, when dealing with RAGs, there would be many challenges that we come across, right? I'm sure people who have worked with RAG pipelines would have come across many challenges. I'm just going to discuss a couple of them very quickly. First limitation is, sorry, I think I jumped ahead. Yeah. So first limitation is when you have composite questions or claims, that is a query that contains multiple questions or claims into one. Okay? That could be a problem. Because then you could run into problems like this, which I'm going to demonstrate. So if we have just one question, we saw that it's able to answer it pretty nicely. Another example of a single question, I just combine these two questions into one. Okay, here. I just combine these two questions into one. And you can see that the first part of the question is answered correctly, but the second part is not, because it did not get the relevant context for that. Because our chunk window retrieval system can concentrate on just one part of the query, right? You can modify that, so we'll discuss that in solutions. What are the solutions for this problem? Well, you can build a complex RAG model somehow, right? Or you can simply pre-process the question and extract the component questions or claims, right? And process them one at a time, RAG them one at a time. So to do that, we have a function here. Just going to skip it, just trust that it'll work. And after we were going to use this function to do the splitting of the query into component questions. So you can see here the question is, what is Ramanujan's birth anniversary celebrated as, and was he a fellow of the Royal Society? Now this is broken down correctly into two separate questions. What is Ramanujan's birth anniversary celebrated as, and was Ramanujan a fellow of the Royal Society? You can see that the pronoun has been correctly replaced by the correct subject, right? So now we can process this very easily with our existing functions. And to show you another example here, but also to show you that if you pass in a query to this function with just one question or claim, it'll not break the system. It'll still work. So this one here just has one question, and it'll just extract one question then, right? So the point here is that when you construct functions like this, you have to take care of these cases also, that it does not break the system when normal cases are passed, right? Another limitation could be when you're looking for an answer, or when you're looking for evidence to support or refute a claim, you might find the relevant context in different places, fragmented across the document. How do you deal with that? Because, you could fetch multiple chunks, right? What are some of the solutions? Well, the first and the most difficult, I think, would be to try to improve the source document quality. That may be possible in certain situations, but in most it will not be possible, right? Another solution could be a multi-chunk merge retrieval system. So you retrieve multiple chunks from multiple different places in the document, and you merge them into one context, into one content that you pass as context. That is slightly simpler, I would say. And the third, the simplest one, would be just to try using a multi-set chunk window retrieval system. That is, you use the same chunk window retrieval system that I showed you, getting one chunk and appending it with 2 chunks before and 2 chunks after, but you do that for multiple chunks that are fragmented across the document. Okay, I think this one is the easiest to implement. I'm not going to show this in the demo. We are running out of time also. So let's go very quickly to evaluation. I'll just take 5 more minutes. Thank you. So let's go quickly to evaluation, because that is an important piece in this talk. Okay? So how do we evaluate? Now we have built a good search system using semantic search, and we have built a good RAG pipeline that serves your need. How do you really evaluate it? How do you know it's really working? How do you know it's, you can test it for 1 or 2 cases, but when you have hundreds of cases or in production, how do you really monitor its quality? So there are many metrics that you can use to evaluate semantic search systems and RAGs. I'm not going to go through all of them. I think we know some of them, like accuracy and precision and others, but I'm going to show you, just due to shortage of time, some of the overall techniques, that you can use to evaluate semantic search. So one could be a supervised learning model evaluation system, where you have, annotated questions and responses in pairs that would do the evaluation of search results given a query. So it can mark it as relevant or not relevant, or give it a score, whatever you want. The other way is to actually use an LLM itself to do the evaluation. Okay? I have that in the demo, but I don't know if we'll have time to go through that. And to evaluate RAG, again, you can have different methodologies, but the one that I recommend, because of complexities in other methods, is to just go with LLM-based frameworks. Okay? One such framework, there are many, but one such that I've been using recently is called TrueLens. Okay? There's another called Deep LLM, I think, or Deep RAG or something like that. I didn't use that very much, so I cannot comment much on that. But I have used TrueLens, and I could show you this, but I think we'll have to skip this because I don't want to eat up somebody else's time. And like I said, I'll be happy to share this notebook with you. Please play around and use it to your advantage. I hope this talk has given us all something to work on and take away. So, a lot of stuff that I'll have to skip, but thank you all for coming and listening. Thank you. Thank you so much.